So we will start our discussion sa basic calculus on this lesson first. Ang cover nito is from topics 1.1, 1.4, which is all about limits. Since sa idea nito, binase halos lahat ng concept sa calculus. So sa math, ang limit ng function ang isa sa fundamental na concept ng calculus. Dahil sa limit, madedefine natin ang derivative, kung familiar kayo dito, and yung tinatawag na definite integral, which you will be encountering at the later discussions in this subject, specifically on differential and integral calculus, kung ititake ninyo when you reach college. So our first topic is all about the limit of a function. Okay, as an introduction, limits are the backbone of calculus, and calculus is called the mathematics of change. The study of limits is necessary in studying change in great detail. The evaluation of a particular limit is what underlies the formulation of the derivative and the integral of a function. Okay, so pag sinabing backbone, it means na ito ang nagsisilbing pundasyon o chief support ng calculus, gaya ng na-mention ko kanina. So para mas maintindihan ang concept ng limit, imagine mo na manonood ka ng isang basketball game. Kapag pipili ka ng mauupuan mo, gugustuhin mong maging pinakamalapit sa aksyon hanggat maaari. Pipiliin mong pumesto malapit sa mga nagbabasketball para magkaroon ka ng pinakamagandang view ng laro, na para bang ikaw ay nasa basketball court mismo. Take note na di ka pwedeng pumunta sa loob ng court at sumali sa mga players, pero magiging malapit ka naman para mailarawan ng malinaw ang detalye ng mga pangyayari ng laro sa court. So parang ganyan din pagdating sa limits ng functions. So dito, i-consider natin yung functions na single lamang ang variable, and pag-aaralan rin natin ang behavior ng function, kung saan siya patungo o ano ang direksyon niya o ano ang magiging value ng function habang ang kanyang variable ay lumalapit patungo sa isang particular na value, which is a constant. Okay, before we proceed to discussion of limits, let's classify functions first. All functions are classified as either algebraic or transcendental. A function is algebraic if the operations involved in the function are combinations of the 6 fundamental algebraic operations, namely addition, subtraction, multiplication, division, evolution, and involution. Example of this is f of x is equals to x cubed plus 2x minus 5 all over x minus 1. A function is transcendental if the equation involves operations other than the 6 algebraic operations. Example of this is f of x is equals to x ln of x plus sin x. So let's define now the limit of a function. Consider a function f of a single variable x. Consider also a constant c which the variable x will approach, where c may or may not be in the domain of f. The limit, to be denoted by L, is the unique real value that f of x will approach as x approaches c. So sabi dyan, let the function in one variable be f of x, and c be any constant, any number with fixed value. There is a condition where c may or may not be in the domain of f. That means, pwedeng di siya included sa input value x. Literally speaking, from the word limit, it is asking kung hanggang saan o anong output value ang i-approach ng f of x na real. kung ang input x niya ay mag-approach din sa isang constant c on its domain kung nag-exist ito. So this is written as, which is read, the limit of f of x as x approaches c is L. So dito sa book ninyo sa Basic Calculus Learners Material, this symbol L represents the limit. This means that as x approaches c, f of x approaches L. So yan, parehas lang ang idea ng dalawa. So dito, ma-analyze o malalaman natin kung ano ang behavior ng function near a particular input. In simple words, limit tells us what the function is doing around a certain value of x. So at the end of this discussion, you are going to illustrate the limit of a function using a table of values and the graph of the function. So first, let's illustrate the limit of a function using a table of values and consider this example. So as you can see from the given mathematical expression, you need to evaluate the given limit. So comparing with the previous notation, we have the one inside the parentheses as the function, which is f of x is equals to 1 plus 3x. And the constant c, the value of interest na i-approach ng x, is 2. Below the limit operation represented by LIM. So here, we will construct a table of values to investigate the limit of 1 plus 3x as x approaches to 2. So we are going to observe how the value of the function changes by finding the corresponding values of f of x to the provided inputs or set of values of x that satisfy the condition x is approaching c listed on a table to evaluate the limit. So ang ating condition sa example na ito ay x approaches to 2. That means, ang pipiliin nating values ng x ay papalapit sa 2. But before that, we know that there are two ways where x approaches to 2, and it can be easily seen on a number line, like this one. These are starting from values on the left and right on either side of 2. First, consider muna natin the value on its left, or simply, yung mga x na less than 2. So we have a table like this one. So we have chosen here inputs from the interval 1, 2, 2. So bawal natin gamitin yung exact number na 2. Recall that x should have any values close to 2. So you can write or insert also here 1.8 and 1.85 after 1.7 instead of 1 and 1.4. Kayong bahala o diskarte na po ninyo basta ma-analyze nyo ng mabuti ang pag-value ng x and to where or what value it approaches. So next, I have assumed that you are already familiar with table of values. So we are obviously going to evaluate the given function using the inputs provided. So kanina, if our input is 1, our output will be 4. For 1.4, ang output naman ay 5.2. Continuing the process, we now have this one. So later on, we will observe where the output is heading as x approaches to c, or here, x is approaching to 2. Now, construct ulit tayo ng table, but this time, with values na greater than, pero malapit sa 2, o galing sa right, papalapit sa 2. So we have this one. So we chose from the interval 3 to 2. Again, you can choose any values you want to be listed on a table basta papalapit sa 2, and regardless kung ilan yung gap between these values, pwedeng 0.1, 0.001, the closer, the better. So we use the function to evaluate the given values for x. So eto yung magiging corresponding outputs. So now, dito sa left, if ang inputs natin ay 1 papuntang 2, ang outputs ay 4 papuntang 7. While on the right side, from 3 to 2, our output will be 10 going down to 7. So observe that the output for our last input here in each table is near 7. So we can say that whenever na papalapit ang x at ang function f of x din natin, which is 1 plus 3x, ay lumalapit sa 7. So that is the behavior of our function here, and we obtained this based sa pag-illustrate natin ng limit through table of values. So kahit anong values ang ilagay natin sa table, as I've said earlier, o anumang direction ang gamitin natin, basta nag-a-approach sa 2, either from left or right, mapapakita natin tong behavior. So that is why the limit for this function, which is 1 plus 3x, as x approaches to 2, is 7. Okay, next example. Example 2. Investigate the limit of absolute value of x as x approaches to 0 through a table of values. So we have here an absolute value function, or we can write f of x is equals to absolute value of x. So we need to find its limit as x approaches to 0 using table of values. So as you can see, the output values are the same, provided that x only differ in signs. So our output here in each table will always be positive. So we will construct first the table of x versus f of x for values of x to the left of 0. So approaching 0 from the left, so our x here is less than 0. Now from the right, so ganito ko yan isulat para di ko yan malito. So dito, mas malaki yung mga values ng x sa 0. So therefore, x here is greater than 0. So looking at the output sa pinakababa, it is obvious that this is approximately equal to 0. Or lahat ng output values, kung maobserbahan natin, ay papalapit ng papalapit sa 0. So since positive lahat, it goes down to 0. So therefore, we have the limit of absolute value of x as x approaches to 0 is equals to 0. Okay, another example. So dito, rational function naman yung f of x. So since rational function to, yung algebraic expression sa denominator ay di pwede maging 0. So we equate it not equals to 0. Kasi magiging undefined pag dinivide natin by 0. So therefore, domain must not be equals to 1. So, di yung problema because we only need input values na close lang sa 1. Di yung 1 mismo. So, di ba, we're only approaching C here, which is 1. Now, these are the table of values first from the left and from the right. Approaching 1. So, obvious naman sa table na as x approaches to 1, f of x approaches negative 3. So, in simples, the limit of x squared minus 5x plus 4 all over x minus 1 as x approaches to 1 is equals to negative 3. Now this time, create naman tayo ng sarili nating tables to solve this problem. We can also write here 1.1, 1.05, 1.01, and 1.001. Also here in the next table, I choose 0.98, 0.99, 0.998, other table, when our input is 0.98, our output is f of 0.98 is equals to negative 3.02. Plugging in the other values of x, we have here negative 3.01, x is less than 4, and x minus 4 squared plus 3 if x is greater than or equal to 4. Okay, so what do you call this kind of function in this problem? This is a piecewise function, if you can still remember sa Gen Math. So, medyo kakaiba ang function dito na kukuhanan natin ng limit. Pero parehas din naman ang ipa-follow nating procedures and ang i-apply nating logic. So, as you can see, may dalawang functional expression with a specified domain. Ibig sabihin, pipili tayo sa given functions kung alin ang gagamitin natin para ma-evaluate yung mga value ng x na nag-satisfy sa condition ng limit, which is papalapit dapat sa 4 to construct the correct table of values. Nagkataon na ang C natin dito ang ginawang reference sa binigay na two domains. So these are the tables of values we will use to illustrate the limit of the function. So first, for x approaching 4 from the left, we all know that this set of values is less than 4. So this f of x right here must be x plus 1 base sa piecewise function. And dito naman, ang mga values ng x mula sa right papalapit sa 4 ay mas malaki sa 4 or greater than 4. Pasok ito sa second domain ng function. Kung paghihiwalayin natin ang inequalities dito, this is the same as x is greater than 4 and x is equals to 4. Pag kinumbine. So, ang values na napili dito, which approaches 4 from the right, ay dapat na i-substitute sa f of x is equals to x minus 4 squared plus 3. So, kung mapapansin ninyo, di parehas ang ina-approach ng f of x base sa na-construct nating mga tables of values. So, yung last na output dito sa first is approximately equals to 5. So, therefore, f of x approaches 5 from the left. And sa pangalawa, the function approaches 3 from the right. So, isusulat natin to na ganito. Wherein yung f of x is nasa right ng 3 para di kayo malipto. So, pag ganito ang lumabas ng mga values, magsusulat tayo ng letters D and E sa katabi ng mathematical expression ng limit, which means that the limit of the function does not exist. So, there are two remarks na dapat nating manotice. Number 1, so ito ay important fact na kailangang i-emphasize. So, mali pag in-equate mo sa D and E ang limit ng isang function if the limit does not exist. Kasi sabi dito, D and E is not a value o wala siyang rin-represent na numero. So, ang ibig sabihin ng D and E sa last example natin ay magkaiba ang direksyon o dalawa ang pinupuntahan ng f of x habang ang variable x niya ay patungo sa C, galing sa left and galing rin sa right. May ibang example na di nag-exist ang limit kasi undefined, gaya ng limit of 1 over x as x approaches to 0 kasi i-divide natin ang 1 dito by 0. For second remark, so dito may mapapansin tayong pattern sa method natin kanina habang ine-investigate natin ang limit gamit ang tables of values. Diba in-specify natin on each table na pag ang x ay mag-a-approach ng constant c mula sa left, ibig sabihin, itong mga values ay mas maliit sa c. And kung mula naman sa right, ang mga values ay mas malaki sa c. So, may specify natin ang bawat direction kung i-add natin itong mga symbols sa ating limit notation. So, kapag galing sa left o less than C, ang isusulat natin ay ganito. And kapag mula naman sa right o greater than C, ganito naman. So, ang tawag dito sa magkabilang limits ay one-sided limits. Since kino-consider o nagpo-focus muna tayo sa mga values sa one side ng C. Therefore, makakonclude natin dito na kapag ang limit ay nag-exist and is equal to L, ganun rin dapat ang limits on the left and right side of C. Parehas nag-exist and equal rin sa L. So in symbols, ganito siya. Therefore, we can say that the limit does not exist if magkaiba ang limits sa bawat side ng C. O pwede rin, parehong di nag-exist ang limit. So, obvious naman, sa iba pang mga previous examples, na halos lahat may limit. Kasi ang limit, o yung numero na ina-approach ng outputs natin sa bawat table of values, ay magkapareho. So, proceed naman tayo sa remaining part ng ating objective. Mag-illustrate naman tayo ng limit ng isang function gamit ang kanyang graph. Dito, kapag alam na natin ang graph, lahat naman ng mga problems involving this ay given na yung graph. So, madali na lang natin madedetermine ang limit ng function as x approaches to c by looking at the vicinity of x is equal to c. Pag sinabing vicinity, it refers to the surrounding area o mga points na close dito sa point where ang x-coordinate ay c sa graph. Let's solve again yung mga examples kanina, but this time, kukunin natin yung limit by looking at the graph of the given functions equated to y. So, considering again the first example kanina, na ang function ay 1 plus 3x. So, its graph will be like this one, a straight line. Also, the graph of x is equal to 2, which is a vertical line, is drawn here, and in broken line. Yung graph pala ng ating function is in solid line dito. So, as you can see, nakaplot na yung points sa table of values kanina, pero yung mga x lang na galing sa right papuntang 2. And it can be seen clearly sa graph na papunta o papalapit yung mga points sa level na 7 yung y-coordinate o ang output natin dito sa ating function. And it is also indicated here by a broken line. So let's inspect the limit using the graph only, without plotting the points from the tables of values. Our condition here is the inputs of the function or the set of values of x must be approaching 2. Let's look at the numbers going to 2. Para mas simple ang ating analysis, let's consider the next number to the left and right of 2. So magsisimula tayo from 1 to 2, then 3 to 2. So sa left muna, we'll start on the point on the graph where x is equal to 1, to the point where x is equal to 2. And ma-observe natin na yung outputs dito sa interval ay papunta sa positive 7. I-start naman tayo sa right side ng 2 na 3 yung value ng x sa graph. Going down towards positive 2, so we'll stop near positive 2. The outputs are still approaching to positive 7. So, na-confirm na natin sa graph na ang limit talaga ng 1 plus 3x as x approaches to 2 is 7. Okay, next example. So, recall natin yung example number 2 ng function ay absolute value of x. So, remember na yung c dito sa limit ay 0. X is equal to 0 is simply our y-axis here. So, naka-broken line ulit siya, indicating na ginawa lang natin siyang reference para mahanap ang limit mula sa graph ng ating function. So, looking at the graph, regardless kung saang x tayo magsisimula, on each side, papalapit sa 0. So, obvious naman na yung corresponding portions nito sa graph will meet at the origin. Or both move downward, approaching our output here, o yung value ng y sa origin, which is 0. So, malinaw na ang limit talaga ng absolute value of x as x approaches to 0 is also 0. Okay, so here, recall natin yung third example. So, ito yung function natin dito. And, di ba, pinapahanap yung limit ng function as x approaches to 1. So, kung i-graph natin tong rational function, yan yung mag-a-appear, which is a straight line. Since kung i-simplify natin to, this is equivalent to x minus 4. Pag finactorize kasi natin yung numerator, makakancel natin yung nasa denominator. So, this 2 is an identity if and only if x is not equal to 1. Kasi di siya included sa domain o magiging undefined ay naging 1. So, itong straight line ay same din sa graph ng y is equals to x minus 4. So, mali itong nasa libro. Pero may hole o di included yung point na 1ux. So, sakto na ang CD natin dito is 1. So, papalapit lang tayo sa 1 for values of x. Di tayo darating mismo sa 1. Kaya okay lang kahit di kasama yung point na x is equals to 1 sa graph. So, to find the limit based sa graph, aalamin natin kung saang level ng y ang i-approach ng corresponding output sa graph habang yung x o inputs sa function natin sa magkabilang side ng 1 ay papalapit rin sa 1. In simple words, titignan natin, referring to the y-axis, kung saan mag-meet ang arrows pag nag-draw tayo dito, which represent yung portion ng graph kung saan papunta yung mga x natin na papalapit sa 1. So, dito, may denote na broken line horizontally indicating kung saan papunta yung mga corresponding outputs natin dito sa graph ng function. So, masasabi natin na ang limit ng function as x approaches to 1 is equal to negative 3. So, dito naman sa example 4 natin kanina, dinivide yung graph into two parts. Kung i-observe natin dito sa magkabilang sides ng 4 by this broken vertical line na graph ng x is equals to 4, which is yung c naman natin dito. So, recall na ang hinahanap dito is the limit of f of x as x approaches to 4. So, magkaiba ang level ng y kung saan papunta ang graph natin pag ang x ay mag-a-approach sa 4. So, mula sa left ng 4, y is equal to 5. Mula naman sa right, y is equal to 3. Since magkaiba ang limit sa bawat side, ang limit ng kabuuang function does not exist. So we have here another example. So madali na lang to kung mag-inspect lang tayo base sa graph. So sa A, obvious sa graph dito sa point na x is equals to negative 2 na ang function sa magkabilang sides ay papuntang 1. Therefore, the limit of f of x as x approaches to negative 2 is equal to 1. For letter B, considering the point where x is equal to 0, automatic that the limit of the function here is 3. So sabi dito, walang bearing yung f of 0 o value ng function pag x is equal to 0, which is yung c natin dito na di nag-exist, o in other words, yung 0 ay di kabilang sa domain ng function. Regardless kung merong point dito, for example, o ibig sabihin, defined yung f of 0 and is equal sa ibang constant other than 3. Yan, for example, 100 or negative 5,000. It doesn't matter also, basta don't forget na ang importante lang dito ay kung anong mangyayari malapit sa c, which is 0, and di mismo sa c itself, which is at the point where x is equal to 0. Lastly, for letter C, the limit does not exist when x approaches to 3, since dalawang magkaibang graph ang malapit sa 3. Our C here, o iba ang pinupuntahan na output o value ng y. So dito naman sa isa pang example, the limit at point 1 on the graph, or as x approaches to 1, is obviously 0. Next example, so ito na yung graph nitong function sa example 3. So to find its limit as x approaches to 4, dito muna tayo magko-consider sa left side ng 4, so papunta siya doon. Sa y is equal to 5. Kaya ang limit ng function as x approaches 4 from the left is 5. And then for the right side, papunta siyang 13. So limit of the function as x approaches 4 from the right is 13. Since magkaiba ang magkabilang limits, therefore there is no limit for the whole function, or the limit does not exist. Now, for our last example, so considering the points na i-highlight sa graph, so sa number 1, the limit of the function as x approaches to negative 2 is 3. Sa number 2 naman, the limit of the function as x approaches to 0 is 5. Sa number 3, the limit does not exist, since the limit of the function as x approaches 3 from the left is 2, and is not the same as the limit of the function as x approaches 3 from the right, which is 3. So that ends our video lesson for today. I hope you have learned something, and thanks for watching.